Hey friends, I just got back from the Twin Cities. I attended a lecture by creationists at the University of Minnesota Twin Cities. It was by Dave and Mary Jo Nutting of the Alpha Omega Institute, which sounds extremely fancy and pretentious, but it really it's an apartment building. I presume it's just where they live. So anyway, they have this institute and they go around giving talks on creationism, and they're extremely repetitive and extremely predictable. There was absolutely nothing surprising about this, but I recorded it anyway for posterity's sake. No, actually, it's because I suffered so much through it that I figure you guys get to suffer too. So I'm going to make you. Now you don't have to listen to it. It's crap, but it's on the record, so I just put it up there. I can summarize it really briefly. It could have been a 5-minute lecture because the same thing was repeated over and over and over again. In this case, what it was is Dave Nutting would present some miracle of biology. The blood clotting pathway, for instance, or marvelous big brains, or countercurrent exchangers in dolphin fins, whatever. He would present it, and then he'd say, "Sure looks designed to me." And he'd go on to his next example. He never presented any background evidence for any of his stuff. He never explained how we know about this, how we measured it. He never gave the evolutionary biologist explanations for these phenomena. He never talked about the data, the molecular evidence, the comparative zoology, anything like that. Just splat. Here's something complicated, therefore design. And really, that's the entire point of his entire lecture, was simply that, conflating function and complexity with design. If it's complex, that implies design. And this is incorrect. This is false. As I pointed out to him in the Q&A, that is a logical error. Because the point under contention is, how did it get to be complex? Complexity is an outcome. That's the answer. That's the observation we make. And then what we have to do is we have to suggest what mechanisms generated that complexity. And if you ask an evolutionary biologist, they'll talk about natural mechanisms. They'll talk about evidence that they've gathered that this particular stuff had precursors. We would look at the molecular basis for it. We'd ask how it was assembled. All that kind of stuff. So that's one alternative. The other alternative is creation, which is that a designer, which the Nuttings were quite plain to say, quite clear about, was the biblical God and Jesus, and that he just sort of put it there over and over and over again. That's all we were reduced to. So it was not very informative. It was not very interesting. It was built entirely on a logical fallacy. Okay, so if you must, go ahead, listen to the audio that follows my little introduction here. You could skip through it. Really, I do recommend skip through it. Where it gets interesting, though, is at the end, at the Q&A. This was a poorly attended talk. There were about 20 people in the audience. Most of them look like students. There look like a few faculty or staff at the university, but mostly students. And they were all critical. They all asked good questions, good, tough questions of these guys. And they were quite clear that, no, they don't believe this creationism stuff. And they were daring the Nuttings to actually explain what they were talking about. So that was kind of heartwarming. That made me feel better. There may have been some creationists there, but they were sitting there meek and silent and afraid to speak up because I kind of boomed out at the Nuttings a few times. Yeah. If you listen to this at the end, I will include a link below to the end and the Q&A at the end, so that because that's the more interesting part. If you listen to that, you will hear my voice coming out like the voice of God, just bellowing out over them. And that's partly because the recorder I had was sitting a foot in front of me on the desk. So I cheated a little bit to get that effect. I was also kind of agitated and loud, so that also contributed. Anyway, enjoy yourself. Listen to this crap if you want. If you don't, just skip ahead to the Q&A, and that's good enough. Okay, talk to you later.
Tonight you have come to chance versus design, and that is under the title of, let's see, the evolution delusion, debunking the agenda of evolution. And so this is our third on-campus presentation, and we had, of course someone wants to call me right now. We had, the first night we talked about biology, the second night we talked about rocks and fossils, and tonight we're just kind of talking about design and comparing it to the evolutionary model. So we're excited that you came tonight. We're honored and we thank you. There's not many of us, but we're still glad, even if we just get a couple, we're always glad to be able to talk about this subject with people that want to think it through, want to bring challenging questions, want to have a good dialogue. So that's what we're excited about. I am Parnell Mahoney. I'm a pastor, campus pastor with with Maranatha Christian Fellowship, the group that hosted the event tonight. And I have been a pastor here for 9 years on campus. And I gave my life to Christ in 1999, I think it was, 97, 99. Over here on campus, I was in the Fisheries and Wildlife program over on, used to be CNR and St. Paul campus, now it's CFANS. And finished my degree there, but decided I was going to be a fisher of men. So that's what I'm fishing for these days. But this issue of creation and evolution came to me when I first became a Christian. I used to believe in evolution. That's how I was raised, of course. Went to public school and all that. Went to university, science program here. And someone at my church challenged me and said, evolution's not in the Bible. So I said, what are you talking about? And I went back to Genesis, and sure enough, I was a young Christian, wasn't raised in a Christian home, so I didn't have any Bible knowledge that was very deep. But there it was, pretty clear that you couldn't really fit it in there. So one of our motivators in this presentation is to try to help Christians. If you're not a Christian, that's okay. We want to help everybody. But the audience that seems maybe a little more receptive, not much these days, but a little more receptive to the creation argument would be those who might believe the Bible, And so we want to help them believe the whole Bible so that their faith can remain strong. And we believe that macro and mega evolution is in stark conflict with Genesis, and we believe Genesis, the first book of the Bible, is meant to be taken literally. It's meant to be. It was written to be received as history, as a historic record, albeit not necessarily incredibly detailed. Certainly if you're going to devote one chapter to the creation of the cosmos and the world, or two chapters, you got to be kind of general, But anyway, we're passionate about this topic. We have a table back there, and we have one more event tomorrow night that I want to mention before we get started, and that is going to be at our campus church. We have flyers for that church on the back table. We also have flyers for the actual event on the back table. So our church meeting starts at 7 o'clock and runs till 9 o'clock. The program starts about 7:50, the presentation by Dave and Mary Jo Nutting. And that program tomorrow night is going to be You Can Believe Your Whole Bible. Subtitle, Is Genesis Just Poetry? Did God Use Evolution? That's going to be the topic tomorrow night at our campus church. So you're welcome to come. You don't have to be a Christian. You don't have to stand up and worship if you don't want to during the worship time. But that's tomorrow night. And we have a sign-up sheet. We have other materials on the back table. You're welcome to grab some candy if you didn't get dinner, or if you want some dessert or something like that. Welcome, you newcomers. All right, so I'm going to talk about Dave and Mary Jo Nutting. They're from Alpha Omega Institute. You can find them at discovercreation.org. And they are basically people that present on creation science, and they've been doing that for 30 years. And they used to believe in evolution, they used to teach evolution. They have both been instructors at the college level, and they have advanced degrees in mathematics, in biology, and in biology with a science education emphasis, and geology. And they are passionate to talk about this. They travel around the world. They sometimes do debates. Generally, they're just doing presentations. And they speak on college campuses. They speak at public high schools, public schools, churches, and they give tours. They regularly go to Costa Rica now and do creation tours in Costa Rica, talking about evidence of design and some animals down in Costa Rica. It's an amazing place down there, as I'm sure some of you are well aware. And they've been to Mongolia, Israel, they've been to Europe and Central America and Canada teaching. And they are passionate to present on science, on philosophy, and on paradigms, and examining those subjects in relation to evolutionary theory and in relation to creation models. So please join me in welcoming Dave and Mary Jo Nutting. Mary Jo is going to speak first. She's going to introduce. Oh, one more thing. I'm sorry, Mary Jo. We're going to have a Q&A after. So the presentation, Dave can get a little long-winded. He has a lot to talk about, so it could be about an hour and 15 minutes, something like that, plus or minus. And then after that, we'll have a Q&A, so we ask that you hold your questions or comments until that time, and then I'll introduce the Q&A when we're ready for that. So I appreciate you coming.
Great. Well, we're glad to be here with you. I actually grew up in Minnesota, down in Mankato. I went to public schools down there, went to the university down there. And then I wanted to go to the mountains, so I went to Colorado and graduated from Colorado State University with a degree in biology and teaching biology after that time, believing in evolution. That was all we were ever taught. And I just accepted it until we started to study this issue on our own after we got out of school. And we started looking at the evidence that was out there for evolution, and we started trying to compare that with what these creationists were saying. And as we looked at it, we became convinced that there was a lot of good evidence showing us that, wait a minute, this evolution model isn't a sold-out case. That, yeah, there is a lot of things that can be interpreted as evidence of evolution, but those same kinds of things oftentimes could be interpreted within a biblical creation model. And what we really looked at was like the difference between microevolution and the general overall theory of evolution, which, you know, is sometimes called cosmic evolution, sometimes called mega evolution, or the overall theory of evolution, starting with Big Bang and then life coming into existence somehow. And eventually, once you get the organisms, then you can get some variation within the created kinds, we believe. But we would call them created kinds. Of course, according to evolution, they might be called species, they might be called subspecies, genus, whatever. But we're going to be looking tonight at some of the specific things that we believe indicate design. And it's kind of like the idea of saying, well, if you find a watch, you can imply there's a watchmaker. And I know that's an old argument, but I think it's still valid, that we can recognize evidence of design. In the end, this is really not a scientific question at the very base level. We might agree on some things about microevolution, but in the end, when we really talk about where did life come from and how did we get all the life forms we have today, we're outside of the realm of observable science. And so we begin to take what we can see in the little bits and pieces and extrapolate from that according to what evolution says. Or we might look at it from a biblical model and say, well, what we see fits with that biblical model. So we're going to be talking about it tonight. There are certain pieces of it that fit with science. There are other pieces that are more philosophical in nature. And so we hope you'll just sit back, listen. At the end of the time, like Parnell said, we'll be glad to take some questions and discussion. And Dave's going to be doing the majority of this presentation tonight. He's really a geologist, by the way. But we've been doing these programs for so many years. I finally got him convinced that living things are more interesting than rocks. And so he's going to take his hand at doing some things with life tonight. And the marvelous things, the marvelous evidences that we see within the living world. So I'm going to turn it over to Dave right away, and then I'll be back down for Q&A later.
Great, thank you. Well, good evening.
Good evening. Press a little black button.
Yeah, something like this. I'm not worried about that. Oh, no, I'll figure it out. I got it. I just may not figure it out how to do it. That.
You want me to help you?
Oh, you can if you want. Okay, this whole idea, thank you, Bacterial, is on the creation versus evolution controversy. And we think that a lot of people will think that, wait a minute, creation is just a religious myth, and evolution is science. Is that too hot, or is that about right?
Keep talking with your,
Okay. Anyhow, but it turns out that both are religious in one way or another. Both require faith, and both can be used to present the data. So that's something important to understand here as we go through that evolution in itself also requires faith, and that faith is in ability of time and chance working through natural processes to basically produce everything. And so in that regard, that is a religious system in itself. I'm going to say this before I duck behind the podium, that evolution is not science. Whoa. Anyhow, it is a philosophy. Basically, it's a philosophy that's posing as science, and actually it is the pillar of what's called a naturalistic worldview. Naturalism is the idea that you can explain everything in the universe, in fact, without there being any intelligence, without a design, without God, basically. And so that's the naturalistic worldview that we see all the time. Let me demonstrate at least the idea of naturalism, okay? I'm not saying evolution here. This is naturalism. How did the universe come into being? According to Discover magazine, which is a magazine committed to the idea of naturalism, they won't use the design word or even God in that particular thing. In their magazine, but they said the universe burst into something from absolutely nothing. Zero. Nada. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. How is that possible? That's a good question, isn't it? That's a very good question. But you understand that that is basically a viewpoint. It is an idea. It is nothing we are going to be able to observe. We might look at some scientific evidence which might support it, or some other evidence that totally contradicts it. But that is an idea. It is a belief system. It is not necessarily science to think that nothing can explode. I believe the evidence cries out that it looks like things were created with a design. And yeah, when we look at life, I see design. People say, no, you can't tell if something is designed or not designed. You can't tell that. And in fact, maybe millions of years of slow and gradual evolutionary changes, working with mutations and then accentuated by natural selection, might be able to make things that you think will be designed. Well, I differ a little bit with that. I think I can recognize design. I know that painting did not come as a result of an explosion in the paint factory, did it? And I know that because I saw my mother paint that thing. All right? So, yes, you can tell design even though you don't see the designer. I look at the living world, I see the same thing. Do you realize that spider web is 5 times stronger than steel? And it's twice as elastic as nylon and remains completely waterproof. How's that possible? Well, that one strand is not a single strand of spider silk. You know, it is actually a network of strands. At the backside of a spider, you see a weaving factory. And that particular weaving factory spins that so that it's not one strand, but it's a very, very strong system of strands that's very fine. And so, yes, it's stronger than steel. They're actually looking at making bulletproof vests out of spider web silk. And I think it's a good idea. We can look at other things too, and I'm going to quickly go through a couple of things because I want to get something to me that's really exciting. But we look at the cooling system of the dolphin. A dolphin's a water mammal, has to stay warm, has to stay cool, doesn't it? The way it regulates its temperature, partly, especially to stay cool, is its dorsal fin. And in that particular process, it acts just like the radiator of your car. And the blood vessels go right alongside with the water, and there's some transfer going on there. Eventually, what's going on is that the blood will go back into the body system and cool the rest of the system. This is actually more efficient than the radiator of your car. And I would say that if your radiator did not happen by accident, then neither did this, okay? Again, Discover magazine, committed to naturalism, says it this way: by all rights, life in the sea should leave a dolphin bait crushed and sterile. This graceful mammal avoids such a fate only by slipping through the loopholes in the laws of physiology. Now stop and evaluate what they just said. Did they give it any explanation? No. They just threw out some scientific sounding jargon, but really didn't say anything, all right? And so it comes up with kind of a hand wave to the idea of naturalism, okay? Giraffes need blood to their brain, and they have special systems in order to do that. And a huge heart, 2.5 to 3 feet long, on that heart of the giraffe. And when we look at that thing, we say, whoa, wait a minute, hold on. That takes a pretty strong heart. A lot of blood pressure too, perhaps. And now you say, okay, with all that blood pressure, what happens when the giraffe bends down to take a drink of water? He should blow his brains right out of his ear, shouldn't he? But we don't see that happening. So there are special controls, special valves. In fact, there are muscles that act like valves in its neck that constrict that flow. There's a spongy mass material that absorbs the very last flow. But I've got a question. Have you ever stood up too fast? You know, the problem's worse for the giraffe, isn't it? And so it stands up when it hears a growl in the bushes and the lion is after it and take off running, right? No, if you stood up too fast, you're going to get dizzy, you're going to fall over. But those muscles relax, and the spongy mass material releases that particular blood into the brain in just exactly a controlled manner, and this particular giraffe doesn't become lion meat. I believe it looks like a created system. Now, we had talked about this just a little bit last night, thinking about the bombardier beetle. To me, a bombardier beetle really looks designed, okay? It really does. It can actually mix those two chemicals together, and when it does that, it can produce basically a fiery blast at 212 degrees Fahrenheit of a solution, liquid and gases, into the face of an approaching frog. And so I look at that and say, how's that possible? How did that happen? Now, maybe you can get the chemicals. Okay, those chemicals are available. But the thing in this particular bombardier beetle is in the actual arrangement of the whole system. You have everything working together in unison: storage compartments, mixing chambers, explosion chambers, several sets of valves. All of it working in unison, to me, is an engineer-type system. And I don't think that's going to happen. Maybe you can get the chemicals. Maybe we could agree on that for those who believe in evolution. But I don't think we're going to get that ordered system by accident. It looks too designed to me. Interesting book that was just written in this year. Basically, inspiration from creation. This is an engineer who wrote this. In fact, he teaches engineering. He teaches mechanical engineering. He's got a lot of awards under his name. Let's see, he's got a PhD, etc., in his field. And he's been working with teams of other researchers in trying to figure out how to make a mechanical knee. And so what they have to do is really study that knee and then try to copy that knee. Interesting, when they're trying to copy that knee, this computer system was crashing all the time. Why? Because there was too much information going into there. Okay? And not only that, they found out it doesn't look to him as an engineer that you could possibly get that knee with all of the particular functions that you have in order to work. Now, I'm not going to go into detail there. I'm just going to recommend that book if you want to pick that up to talk more about that one. What's that? Looks like broccoli. Yeah. No, it's the foot of the gecko lizard, actually. When you look at the scanning mitron microscope at the actual pad on the one of the toes of this particular gecko lizard, you find out there's probably around 300 million strands per square inch, this fiber. And they are so fine, they make a molecular bond with the surface that it is touching. Okay, that's why you can see a gecko lizard run across a plate glass ceiling. And it has a funny gait. So it kind of moves forward, but it kind of also goes backwards like this. What's happening? Well, those bonds are directional. And being directional, they have to be released, don't they, in order to be able to move. Otherwise, poor gecko's stuck for life with the molecular bonds. But no, it's a wonderful system that somehow got worked out. In fact, engineers are actually copying that particular system too. And it took several millions of dollars worth of research in order to do it. And sure enough, they're making a fabric, kind of like a one-sided Velcro. And that particular Velcro, they're hoping to make Sticky Man, or Spider-Man gloves, you might say. They call it sticky tape. And wouldn't that be nice for window washers? On the top of one of these big tall buildings? Yeah, wouldn't have to have all the ropes. Except when you're doing this, you're bound to hit the right direction and oof, down you go. Wouldn't be so good. If I have to copy something that I say God made, okay, to make a better adhesive, I think somebody designed it in the first place. That's my thinking about it. Sea anemones are actually hunting. That guy has at the end of every one of those tentacles is a poison dart capsule. It's got a trigger, a trapdoor, it's spring-loaded, poison-tipped. Fish comes along, hits that particular trigger, bam, this missile fires, and this creature now gets a meal, doesn't he? But think about it. How would you like to eat one of those things? Think about two. Do missiles happen by accident? I don't think so. I don't think that happened by accident. It looks like a design system to me. Well, you wouldn't want to eat it, but there is something that actually eats the sea anemone, swallows it whole. It's called the sea slug. And it swallows that whole thing. Everything's digested except for the poison dart capsules. And now, what's he going to do with those poison dart capsules? Well, notice he has tentacles of his own. And he takes these particular darts, missiles, you might say, that are in his stomach now, ferries them through straw-like structure with cilia, and he actually puts them in place. Once put in place, first fish comes along, hits that trigger, bam, this missile fires. So what you are looking at is a creature that pirates another's missile system and uses it for his own. To me, that's going to be hard to explain, the interaction between the different animals that you see. and the complex arrangement of parts, the whole thing. Woodpeckers basically make their living hitting their head against a tree, don't they? And they're hearing a bug on the inside of the bark of the tree, and they're going after it. They hit their head with such a force, they should fold up their beak like an accordion, their eyes should pop out of their head, but they don't because of special design features, okay? Like the film that comes over its eye every time he hits his head against a tree. And that keeps his eyeballs in and the wood chips out. Extremely important, okay? So it's a living jackhammer, and he's hungry, and he's going after that bug, but you know, bugs aren't stupid. They hear this guy coming, they're going to scooch, aren't they? They're going to get out of there, kind of crawl down one of their tunnels and would be safe, except for the fact that the woodpecker has a very long tongue with sticky barbules on the end of it. And that tongue is about 4.5 times longer than his skull. Okay? And he slaps that down into that tunnel, gets that bug, and he's got his meal. My question I have here is, how is he going to put it back in his mouth? What's he going to do? If he leaves it hang out, it's so long, you know, he's going to peck a hole in it, right? He doesn't have a shirt pocket to put it in. So here's the actual storage compartment for woodpeckers and flickers, etc. That tongue comes out of the back of the mouth, wraps around the skull, attaches up there in the beak region. It's stretchy like a rubber band, and there are special muscles that pull us down into the chest cavity. And so, which came first, if evolution is true? The long tongue or the storage compartment? Both of them have to be there, right? And so, what good is the long tongue without the storage compartment? It could be lethal, couldn't it? But what good is a pre-evolved storage compartment without a long tongue? You understand that these are systems that are working together, to me, look engineered. You know, we also talk about tremendous design of the eye, but Richard Dawkins says, what do you mean, good design? That's absurd design. And basically he says, I can make one better than that. And there's a mass material in the line of the vision, put it over to the side, like in a squid's eye, presto, you're going to have a better eye. Well, that sounds really good, except for one thing. If Richard Dawkins would walk outside on a bright sunny day, in a very short time, he's going to be blind. Because that mass of material he wants to get rid of is the best pair of sunglasses he could own. So basically, I'm going to think that maybe whoever designed this eye knew what he was doing for all kinds of different environments. Anyhow, that whole argument is called an argument from perceived imperfection. We think we can do it better, and therefore we try to make the idea of, well, there can't be a God who designed it in the first place. And that doesn't really work too well. Another thing Richard Dawkins actually says, he talks about what you eat with. He says, do you realize that you actually swallow food with the very same tube that you breathe through? Why, you could choke to death. And he actually called this particular design on one of his publications, the height of stupidity. The height of stupidity. Wow. Well, let me ask you this. Is it really that bad of a design? If Richard Dawkins is correct, all right, where would he put an extra tube? I believe this whole thing is not only well designed, but it's superbly engineered, kind of like a Swiss Army knife. Everything working together. What happens if you only have, if you have another tube? Well, if you get something caught in your throat, you don't have that air to push that thing out, right? So how do you get it out? You have to send a fish hook down there, right? Maybe a big plunger, boom, boom. This is one way or another. I think it's well designed. And by the way, it even makes speech possible. I can't even be up or down here tonight speaking without this particular contraption the way it is, because speech is not only the air and the what goes through, but also it has to do with the position of the tongue, the teeth, and the mouth. all working together in unison like a superbly engineered Swiss Army knife. And that's what I consider this to be, okay? And yeah, you can choke to death. I will have to agree with you. You can choke to death, but how many sitting here tonight actually choke to death today? Okay, so something is actually working, isn't it? All right? Well, the Dawkins also claims, and I hate to pick on Dawkins, but he's been coming up with a lot of stuff lately, and a lot of people I run into at the universities are actually using his arguments. He says that the left recurrent laryngeal nerve doesn't work too well. He says one nerve actually serves the larynx, okay, just exactly the way it should, nice short distance from the brain to it, but the other one, whoa, man, it goes clear around the heart before it gets up there. He said that's a waste. And then he tries to, again, suggest that it's because of our fish ancestry and way back in our evolutionary history. So if it's wasteful, he said, or it's a bad design, it means it must be the product of evolution. So that's what he's saying. Well, it turns out that I believe the design might be for some other reason. Okay? Here are the questions you might ask before you just say it's a poor design. Does the design result from developmental constraints? You'd have to really look into it, right? To say something is poor, is badly designed, you have to know the mind of the designer, wouldn't you? Okay? Maybe there are other options. Maybe we ought to do some research on it. It turns out that design serves to fine-tune the function, allowing you to do accurate speech, okay? And not only that, this nerve actually serves other organs. A lot of people don't know that. It branches from the vagus nerve on its way to the larynx. Upper esophagus is one of the things it services, the trachea, the inferior pharynx, and, wait a minute, other things too. And it actually services the heart. Did you know that? So I think it had other uses as well. And it can also save your life. Why? Because if you go to the doctor and you say, oh, doc, it hurts, and you are slurring your speech, guess what? He knows right away what's wrong, get you to the hospital immediately before your aorta bursts. Okay? It can save your life. My computer is well designed, but you know, your brain is much better designed than my computer. Did you know that? Yeah, it is. It's much more designed. It can do things a lot faster, etc. My contention is if my computer was well designed, yours is better, and it tells me that your computer was designed too, your brain. Okay? The total number of synapses in one brain is roughly equals the number of stars in 1,500 Milky Way galaxies. Realize that's a bunch? That's a good ballpark figure for how many that is. A single human brain has more switches than all the computers and routers and internet connections on Earth. That's a bunch too. You see, it's not a simple thing. Okay, so how would naturalism explain the development of the brain? And here's one I saw. Perhaps an early cell billions of years ago developed a sensitivity to other cells. Then it is conceivable it would be on its way to becoming a human brain. Okay, well, that sounds good, but that's a naturalistic explanation. It's an idea, and that's the start of science, isn't it? But it's not necessarily showing you how it did it. It's just an idea. So that kind of idea got knocked a little bit. They're working on these crustaceans. They took a scan on it in the fossil record. It's found clear down in the Cambrian, and they found out it had an extremely complex brain, just like crustaceans like that today. And so they're saying, whoa, wait a minute, hold on. This kind of negates that millions and millions of years of evolution to produce that brain. It's already there. Think about the DNA is like a computer system. We're talking about computers too, and brains, aren't we? The DNA is like a language, isn't it? There's a whole computer package within your systems. And you say, did that happen by accident? Now, DNA, yes, you can have some mistakes, can't you? You can have some mutations, you can have other things going on. But there was actually a Nobel Prize that was awarded for the discovery of DNA repair. And what happens is the strand sends down, there's an electron that gets sent down the strand. If it encounters a problem, it doesn't go any further. And then there are some proteins, etc., protein loaders, I'm going to call them, that are dispatched to repair the site. Okay, so this is really intriguing. You can read that if you want in the publications here for their DNA Nobel Prize here. Now, I've got a problem with that. There's problems with evolution with this whole mechanism. The repair mechanism requires and integrates with many equally complex system networks. All right, the plot thickens. It gets a whole lot more complex. It's kind of like peeling an onion. When you look at one thing, then you say, whoa, man, is this absolutely complex. But then when you actually delve into it a little further, you find that complexity even has another layer of complexity below that and another one below that. To me, that speaks of a marvelous engineered design system when you actually see it. So how did these mechanisms actually evolve? By slow and gradual processes. Right? Other problems with it, how do important evolutionary mutations keep from getting fixed, okay, or repaired? And this whole thing supposedly evolved chemical soup in a toxic environment. How did that happen? Where it would actually be destroyed really quickly. I was actually doing a lecture, and I had one university instructor tell me this: whoa, that's just it. It's too perfect. No God could have designed that. Wait a minute, if it has imperfection, it can't be a designer, it can't be a God. If it's too perfect, there can't be a God. I don't think we can have it both ways, okay? Things are looking really, really complex. I don't care which one of these I'm talking about. It looks to me like it's a design. But keep in mind, I'm a little biased that way, aren't I? I'll admit that. No problem there. But there's an answer to every one of these design things that I've been talking about so far, anyhow. And that answer is this: from a naturalistic worldview, we can imagine how mutations working with natural selection acting over millions of years might refine systems. I'm sure you all know that. You hear that all the time, don't you? The key to evolution and the driving force is mutation and natural selection. But to say that, imagine, might start the scientific investigation, all right? But the problem is, imagining it doesn't mean that that happened, okay? Doesn't mean that. Coming up with an actual scenario and actually showing it and demonstrating it is another idea entirely. And so you also have to have something there to refine in the first place, don't you? You have to have something to start with. So how do you get that? All right. Well, think about just a couple of things. Many of you already know all about your skin, right? And did you realize it's a little more complex than just this little layer of cells on top? It's a whole lot more complex. And in fact, you have several layers here for your skin. And think about just the hair shaft right here. Got little hairs poking up through there. Well, recognize that every one of those hair shafts, there's a nerve fiber there, and there's also a blood vessel to each one of those. Also, many different layers in this particular skin. You have sweat pores. You've got interesting glands around that particular fiber. That's very necessary because you have oil. You need oil on your skin to keep things lubricated here. And those are the glands that do that. So you have an insulating property. This is also heat sensing. Do you realize when you pick up something, most of the time you drop it before it actually burns you because the heat sensors are so good. It's a very highly tuned. Touch sensing as well. Your fingers can actually detect things better than most touch sensors that are mechanically produced, okay? It's vitamin D production. It can seal the inner part of your body from disease, etc., and from germs, and for cooling. They all work together there. Now, I don't have to talk about the great detail about it, but think about your pain sensor. You don't even think about it when you walk. Do you realize when you walk, you're not always walking on the very same part of your foot? Do you know that? On the very same part or section of cells. Because as you walk, all of a sudden, if you keep walking on the same one, you are going to hurt those nerves. You're going to hurt those cells. So there's sensors in here that communicate with the brain back and forth all the time. And it allows you to be working and walking on different sections of that bottom of the foot, continuing. And you don't even have to think about it, do you? It's an amazing system that's going in here. And an engineer will look at that and say, I think it looks engineered because we can't develop those kind of pain sensors in the pressure distribution here. And the skin can actually maintain and repair itself. An engineer looks at that and he said, boy, I wish we could develop a system that could repair itself. Wouldn't it be great if your computer could repair itself? Yeah, it'd be really great. But the cells on your foot, on your hand, wherever's on your body can actually maintain itself and repair itself. And when there's some wear on the outer part of your skin, guess what? What happens? There's other cells all ready to come into place here and to replace those more damaged cells. The ability to grip. That's another thing too. Just think about it here. When you grip something, frequently what happens is if you can grip it only at one spot, it may not work so well, but your whole hands will work when all the fingers will work in unison so that you're exerting an even pressure. Okay? That's an even pressure, well distributed. It's an engineering feat for sure when those are studying the mechanics of it. And that allows you to be able to pick, say, tomatoes with a very thin skin. You can actually do it with, and not bruise the thing or squish it or whatever. Now, they use mechanical pickers for tomatoes, don't they? You can only use mechanical pickers for thick-skinned tomatoes. Otherwise, you damage it. The thin-skinned tomatoes are only used by hand picking because your sensors and your pressure is so well distributed, it works so that you can actually pick it without damaging the fruit. All right? Now, an engineer looks at this and say, how did they figure out the mechanics of that? Okay? It really is important. So how's the idea of mutations and natural selection? How does that work? That's the primary axiom of evolution, isn't it? Things proceed. Evolution proceeds. Things are perfected by mutations, which are basically chance most of the time. They're accidents. And then they're saved by natural selection, survival of the fittest, aren't they? Well, Dr. John Sanford wrote a book called Genetic Entropy, all right? And this guy is a whole lot smarter than I am. I'll have to tell you that. His whole idea is that the primary axiom, mutation and natural selection, doesn't work. Now let that sink in for a second. Now, who is John Sanford? All right, retired Cornell University professor, genetic researcher, 70+ scientific articles, peer-reviewed, by the way, 25 patents, co-inventor of the gene gun process. The guy really knows what he's doing. And his research, in fact, he even started his research because he recognized the problem in the human race. It noted the problem of too much gene, you might say mutational buildup and things like that. So he was hoping to be able to save the human race, you might say, through research. The more he researched and researched, as a staunch evolutionist at that point, okay, he was also an atheist at that point. The more he researched, he said, wait a minute, hold on. We have a problem with mutation and natural selection, and that's what his scientific research pointed him to. He said careful analysis on many levels consistently reveals that the primary axiom, mutation and natural selection, is absolutely wrong. He continued, he says, it is not just implausible, it is not just unlikely, it is absolutely dead wrong. It is not just a false axiom, it is an unsupported and discredited hypothesis which can be confidently rejected. Like Parnell, like me, okay? What did he end up doing? Later he realized, I think there was a creator who started it all. And but he became a creationist. He became a creationist because of his scientific research. Okay? That's why he did it. But he came out atheism that way. Think about that whole idea. We can imagine the mutation and natural selection acting over millions of years. Dr. John Sanford would say, no, it doesn't work. We can imagine it, but scientifically, it doesn't work. It doesn't fit. And there's another book that was written in 2018 as well, this year, called Replacing Darwin. I'd also recommend this book if anybody hasn't seen it. The author of it, Jensen here, is actually a PhD in molecular biology from Harvard, okay? And he's basically showing how mutation natural selection doesn't work too. And the fact is the number of mutations that we actually are having. Okay, there's so many that are needed, we don't even have time. Even if the, you know, like for instance, human evolution, to be able to explain human evolution for over 2 million years, there's not enough time, even in 2 million years, to be able to explain the number of mutations that are necessary in order for this to happen. Okay, read the book or talk to Mary Jo about it if you want to know more information on that one. I've been getting in pieces of that, but I have not gone through his logic that he's built up in here. Well, Darwin wrote a book called, not Darwin, Michael Bay wrote a book called Darwin's Black Box. Some of you are familiar with that. There he introduced an idea of irreducible complexity. And his idea was this, that there are systems, there are even animals and parts of what you're looking at, that if you eliminate one part, the whole doesn't work. And so he says, in order for this all to work, you're going to have to get everything in place and working at the very same time. He called it irreducible complexity. Well, we're going to get to that, and we're going to talk about it a little bit. A lot of the things we're going to be looking at, I think, are irreducibly complex. Think about a cascade system. Have you ever heard of that before? Where one thing happens to this and sets up a trigger of stuff, boom, 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 all the way down? Or a Rudy Goldberg machine, have you seen those? Right? Somehow this happens over here, and after about 50 steps, the fox gets the shot put dropped on his head. Right? But those are called Rudy Goldberg. If you eliminate one of those steps, the whole thing doesn't work. All you have is one piece of it, but doesn't give you the effect that is necessary. And a question, I've had this up here for a little bit, which one of those wasn't designed? If you had to make a choice, everybody was going to say, well, especially if we believe in naturalism, we're going to say neither of these were designed, but that one was designed. However, we do realize the hummingbird and the dragonfly can outmaneuver that airplane. It can't quite lift as much as the airplane, but then again, it's not as big either. So you would have to say, if these things are more efficient than that, I believe those were designed. That's been my observation on that, okay? Think about that dragonfly, okay? Do you realize it can lift between 15 to 25 times its body weight? It's amazing how those wings flap and how that works, okay? It's absolutely amazing. And this book that we're talking about from engineer Stuart Burgess, Inspiration from Creation, published this year, basically talks about looking at the dragonfly and what they're trying to do, like he was going to try to make an artificial knee. That's one of the projects he worked on with his team. He also decided to make a robotic dragonfly, okay? And in order to be able to figure out the flight pattern, etc., how this thing works, how it can maneuver, how it can hover, and like a hummingbird as well. But when he did it, they put it in, they caught, that was the fun part, they said, was catching dragonflies all over the university grounds, okay? Getting all these dragonflies, putting them in these particular special tunnels to be able to observe things and taking slow motion video, eventually trying to work out the mechanics of this. How does this thing work? Well, recognize a dragonfly has 4 wings, doesn't it? Their computer wouldn't handle it. They had to only do it with 2 wings, okay? And so that's what they ended up doing with the model. It was 2 wings. And basically, they had a horrible time trying to figure it out. And finally, they came up with a mechanism that worked that actually resembles the mechanism on a dragonfly wing. And you see these, the red and the yellow here? Those are the input bars driven by a motor. Okay, so wait a minute, we've got to have a motor doing this, right? Okay, well his system had a motor, and the motor was in miniature, of course, and basically the motor can basically do both of these mechanisms at the same time, like a dragonfly would do. So they basically figured it out, and yeah, they made a prototype of a dragonfly. After much research, many times, going back and forth in the lab, they finally figured one out, okay? But it took them a long time, and a lot of grant money as well. So to me, if it took them that long to figure it out, then that was designed as well. Especially when they realized that the dragonfly was still thousands of times probably more complex than their model, okay? And so their conclusion with that is that that dragonfly looks like it was basically designed. But this is very important too. In the design, notice the 4 pieces. This is what he would call a 4-bar mechanical system. What that means, even though there are 4 bars there, okay? But that isn't what he means. A 4-bar means that if you eliminate any one piece of that, it won't work. Shuts it down entirely, okay? Now he's applied then in his book 4-bar thinking to other things as well, okay? So that's 4-bar thinking. And if you eliminate one of these pieces, it's not going to work. His question that he started asking was, how did the original one accidentally evolve? What part can you take take away and still have it work. And so his idea and the whole title of his book is let's look at what the design in nature and let's get ideas for new systems in mechanical engineering, say. He says, you know, this is a good idea. And the reason is because, yes, you can go in, you can copy somebody's design and try to perfect it and everything like that, but you have all these copyright infringements, etc. When you look at nature, you don't have to worry about copyrights. All right? You go, you do your research. And that's what he was doing here. Anyhow, I like what he said when he started studying about the whole thing of the dragonfly. It starts out as a larva, you know. It lives in water for maybe up to 4 years, I think. He says, it's kind of, this dragonfly is kind of like a submarine. That's a larval stage. That is also an amphibious vehicle that can climb out of water and then turn into a helicopter without any factory or group of mechanics to help. Good point, isn't it? All of this stuff has to be working and operating. And he says he doesn't think evolution's going to catch it. How many got a cut in the last 100 years? Raise your hand. We all did, didn't we? The reason we didn't die is because of our blood clotting system. And this is very simplified, very, very simplified. You have a substance in your blood right now called fibrinogen, but this is the active part called fibrin. And fibrin is what's going to make your blood clot. It's a long, sticky molecule. When you get a cut, you're going to have a bunch of these kind of go across that blood vessel, and the red blood cells will get trapped behind it, and that's going to make your clot. Yeah, it's simplified for you medical doctors. Okay, so it's definitely for me to understand it. It has to be simple. But anyhow, so what do we have here? Fibrin, if you have a bunch of that in your blood right now, you're a goner. It's going to make blood clots throughout your entire system. So fibrin has to exist in that inactive form called fibrinogen. And when you get a cut, something's got to turn it on. What turns on the fibrinogen? Well, the piece of this word, thrombin. Thrombin turns on the fibrinogen, makes your blood clot. Pretty good. Now what happens if you have a bunch of thrombin in your blood right now? It turns on all of the fibrinogen. You are dead again, aren't you? So it exists in the inactive form called prothrombin. Well, something's got to turn it on. Well, what is that? An activated form of the Stewart factor. Okay? That's what turns it on. Make it a little shorter. You need all these things plus a whole bunch more. Everyone is needed. Everyone needs to be turned on. The entire system works or none of it works at all. It's basically a cascade type system too, isn't it? Okay? And my question is, how do we do that? How do we do that? By slow and gradual processes to form something like that. And I don't want you to think that this is simple. How do you even turn on the Stewart factor? How do you activate it? Well, here are the steps right here. There are so many chemicals involved. It looks like they ran out of names and called one of them the Christmas factor, didn't they? You see, to me, all of this working in unison, what does it show me? It looks like it was designed. That's what it looks like. It's an engineering system in order to come up with that kind of thing. Well, what does Scientific American say about it? Okay? I don't think they're being very scientific in Scientific American, but here's what they say. It says, the blood clotting system seems to involve the modification and elaboration of proteins that were originally used in digestion. Okay, so it might have been used somewhere else. According to studies by Russell Doolittle of the University of California, San Diego. So some of the complexity that Behe calls proof of intelligent design is not irreducible at all. Okay, so now I've had a lot of students say, well, haven't you read Scientific American? It explains that whole thing about irreducible complexity. I say, well, have you read the answer in Scientific American? And I'm just highlighting a couple of things by Dr. Jonathan Cervantes. what he basically answered this whole thing, and Dr. Servati is an expert in the field as well. He said this is once more a lot of bluff by the atheist Doolittle, or at least poor reading comprehension. And then he cited different things about maybe if you can eliminate one thing, you might be able to do it. It might work. The problem is, yes, you can eliminate one thing, or two things, it looks like, in that whole system. And basically, and it works. Oh, right? It may not be very functional, but it works. The problem is that, and it would, you know, you wouldn't have to worry about the clots, but the problem is the thing that they ended up with doesn't even have a functional clotting system. So that's not going to help any, right? The next step might have one of them, and because you have that next step, you would be selected against because of uncleared clots. So what are they saying here? You might come up with an idea and throw it out and say, does that really make sense when you actually evaluate it? And the answer is no. Molecular motor is another one that Michael Bay has used a lot. And basically he talks about the flagellum. And when you actually look at this, you have a whole system of proteins working in unison. There's about 40 of them here, all together. And what this does is take, say, the bacteria, and when this thing starts turning, it can turn at up to 30 to 100,000 revolutions per minute. That's an amazing ability to be able to do that, okay? It looks like an engineer made that. There are actually proteins working and forming what we would call in our electric motor system, we call them rotors and stators and drive shafts and bushings and the whole thing. It works just like that. And so he said, you eliminate any part of this, this whole thing collapses. It doesn't work at all. So that was one of his things that he talked a lot about. The problem now, Scientific American. And basically they came up with 1 point, 2 point, 3 points, okay? All right, now let's look at it. Here's point 1, answered by Dr. Jonathan Servati as well. He says basically their point 1 misuses the research of Dr. Scott Minish. And they were quoting a research, and they said they're misusing it, okay? By the way, Scott Minish, a world-class expert on the flagellum, he says his belief in design has given him many research insights. Bio-inspiration, in other words, right? Giving him insights for his own research. He says basically that the flagellum won't form above 37 degrees centigrade. All right, so this kind of shoots some of this down. But he said, too, Minish said it was a degeneration from the flagellum. It didn't go from becoming the flagellum, it was a degeneration of it too. Here's another one. I like this. Even though you have all the right pieces and you've got them sitting in a lab, okay? He said this. The Scientific American's argument is like claiming that the components of an electric motor already exist in an electrical shop. They could assemble themselves into a working motor. But he says this, the right organization with the pieces is just as important as the right components. Same thing with the bomb-eater beetle, right? You might have the right components, but it's the organization that's going to make it work, all right? So that's what he's actually saying. Naturalism actually says, in Scientific American, the final evolution of the flagellum might then have involved only the novel recombination of sophisticated parts that initially evolved for other purposes. That's a might, may have, might have, could have argument here, but here's what Minish actually pointed out. Minish points out that only about 10 of the 40 components, the 10 on the flagellum, can be explained by co-option, but the other 30 of the 40 are brand new. Also, the very process of assembly in the right sequence requires other regulatory machines. Wait a minute. And so is in itself irreducible complex. Did I say the word machines? That's what they said, right? And sure enough, machines. I want to talk about those kind of things right now. And I think this really does show that there's some problems with the naturalistic explanation of things. For instance, look at the ribosome. It's an RNA machine, okay? It encodes more than 300 proteins and RNAs. I mean, this is quite a complex here. Now, first of all, the ribosome. This is the cell here. Whoops, come back here. You see all these little dots right here? Those are the ribosomes. All those little dots. There's a bunch of them in the cell. A bunch of them in that cell. Okay, now, so what they're saying here is the ribosome is actually a machine. Okay? And what does this machine do? Remember, the DNA is kind of strand. There's a messenger RNA comes along. You know, there's a zipper in there, takes it apart. The messenger RNA takes it, puts it into the ribosome. And then what happens here? Then the ribosome actually is playing the crucial role in making this protein. Okay? It's the crucial role. It's making the protein, basically, in the cell. So ribosomes are very important for protein production, aren't they? And we have all of these machines that are going on. And you're going to look at it a little bit more. But first of all, the protein manufacturing machine. Here's what's going on here. You've got the ribosome that consists of RNA and many proteins, over 300 of them. And then, wait a minute, you've got to think about another thing. When you're producing proteins, you better not produce way too many or too few, right? So you also have another motor that regulates the DNA, okay? And it controls the amount of proteins produced. Once that particular protein is made, it's a long string of amino acids, basically. Now it's got another function. You've got to fold that thing into a workable shape that's specific for the function that it is going to utilize or do, okay? So, all of this stuff is working together, and these are all machines. Now, if you want to go to YouTube, that's always a good spot to get our science, right? But there's interesting stuff there, okay? Interesting, like a TED Talk. One was talking about the folding, and basically they made this point. There were over 20,000 real, and he called them real, molecular machines in humans alone. Wait a minute, did you count them? Did you see? You probably don't know that they're even working, but they are. These are real molecular machines. They do folding. They're pumps, they're valves, they're force generators, energy producers like the ATP synthase. Label for delivery for the proteins once they are made where they're supposed to go. Propellers, like in motorboats. There's a whole bunch of these things. And you'll find out who was actually stated that in a little bit, okay? Let's think about the ATP synthase. I'm sure many of you know a whole lot more about this than I do, and that's okay. But when I look at it, as a geologist, I see tremendous evidence in design. I really, really do. And a whole lot more design than I see in a rock. Okay, let's put it that way. But it's interesting. As I really started studying all this stuff in genetics, etc., I'm just loving it. Absolutely been loving it. And there's so much neat stuff out there. And I hope you do too. I'm just saying, wow, isn't it amazing? But you know what? I've realize one thing. I could probably study on this genetics for 50 years and still not know anything. And even what I did learn in the next 5 years is probably going to be all new stuff out there that we never even considered. And maybe some of the stuff we thought was a fact is now no longer valid, okay? All right, here's the synthase machine makes crucial energy. Do you realize all your cells in your body need energy, right? That energy is important for every function that you're doing. You wouldn't even be here without this, without the ATP, adenosine triphosphate. You wouldn't be here. David Godsell, who is a cell biologist, molecular machine modeler, said this ATP synthase is one of the wonders of the molecular world. Just like the flagellum and the motor that produces it, this is a wonder. How did that happen by accident? It's basically 32 protein based. It has two distinct rotary motors joined by a stator, and the whole thing is powered by protons. Okay? Now, let's get another look at this thing. And basically, the protons are actually brought in here, and you notice protons even come out of the system, but this whole machine is basically proton generated at first. And what this does is take ADP, and now it's going to make adenosine triphosphate, and it's going to crush it together. This is a molecular machine that crushes these things together to make the energy. The central rotor spins at over 9,000 revolutions per minute. Very efficient machine. And so when you think about this, you say, how did that one come into being? By natural processes. This is all protein-based. Okay? Just proteins. Did they just happen to randomly get together at the right spot? Or was it that somehow they were designed specifically when the proteins were folded to the right shape? And now there's another machine that actually labels it. It knows exactly where it's supposed to go in the cell, and it goes there. So there's a labeling machine in there too then. Okay. By the way, there's also highways in those cells. There's a highway right here made up of proteins, etc. And wait a minute, it's a microtubular highway. There's the construction. Why are you constructing the highway? Because the contractors know what's coming down the pike. Okay, what's coming down the pike? Turns out to be this thing, carrying proteins and energy and everything like that with it. And it goes in and services the cell. And think about it. This is the transport machine. This little guy here, you think, it almost looks like somebody stepping, right? Right? It's a UPS delivery guy. But he's a little faster than your UPS delivery guy. He's actually moving, for the size, when you actually compute it, about 1,200 miles per hour. I mean, that's going fast, isn't it? He's delivering this into the rest of the cell. The power to weight ratio is 15 times what you find in a gas engine. And the engineers are looking at that and saying, how can we copy that? Especially now with the age of miniaturization, they're trying to copy it with this whole idea in mind of making miniature motors, copying the cell. That's what they're doing right there. If you want to read more about molecular motors, here's a list, not 20,000 of them, as was suggested. Here's a list of about 40 of them. You can go find it right here. 40 of them in the cell. Casey Luskin, go look for him, July 11, 2010. Do a Google search on him, you'll find it, okay? But anyhow, 40 of them in order to take one of which makes energy, another one actually folds protein perfectly. Howard Berg from Harvard University said it this way: these machines are the most efficient machines in the universe. Better than anything man-made, by the way. Okay, that's what they're saying. How many have heard that most of the DNA in your body was junk, left over from millions of years of evolution? Yeah, we've heard that for years and years, haven't we? Of course you have. That's what I grew up with too. But the problem here is not junk. Not junk. Okay? We predicted, I remember 10 years ago, roughly, Mary Jo was actually talking at the university and said, this junk DNA, I predict they're going to find a function for that. That was her prediction from a creationist viewpoint that God doesn't make junk, probably, and that we need to do the research. Even though we don't have a function for it now, keep digging. You're going to find a function. That was her prediction as well. And so that's a predictive value here. Well, started reading things like this one, Dr. John Sanford, geneticist. We talked about him a little bit ago. He said, it is becoming increasingly clear that most or all of the genome is functional, not junk, okay? The ENCODE project came along in basically results published after several years of research, published in 2012, basically as they're working on trying to come up and to read and order the genome, etc. And they looked at that junk DNA and they found out this metaphor of junk isn't that useful anymore. Why? Because they're starting to find lots of uses for the stuff they've been calling junk DNA. Discover magazine actually said it this way. The key point is, it's not junk, okay? It's not junk. Here are some of the uses, and you can look at them right here, okay? Well, let me go down to the bottom here. There's a bunch of them. These numbers refer to all kinds of different scientific articles, by the way. Here's one, the helping to fight disease. That's important. How about regulating embryological development? That's extremely important. You wouldn't even be here if it wasn't for this stuff called junk DNA. You may have heard of pseudogenes. According to the online definition from pseudogene.org, pseudogenes are genomic DNA sequences similar to normal genes but non-functional. They are regarded as defunct relatives of functional genes. Well, is that what they really are? That's what is in the textbooks. All right. Well, here's an article. RNA biology, and this is their title, pseudogenes are not pseudo anymore. Uh-oh. They're finding out they were wrong. Okay. All right, here's another one. This particular article, you recognize probably some of these names, but pseudogenes, pseudo-functional or key regulators in health and disease. So we're starting to find that even pseudogenes are having a major function. Mary Jo's prediction, I believe, has been verified. It looks designed. It looks, it was not junk. Well, Dr. Dawkins had stated one thing, that you look at how you're going to get the amino acid glycine, that's actually is one of those beads in the protein, you might say. He said there's four separate ways to get the amino acid glycine. He said, wait a minute, they all differ just by this last letter. He said that's redundant, it's wasteful. There's no creator that would have done that. Such a wasteful design. That's a product of evolution, okay? Well, it turns out it wasn't wasteful at all. And we have to understand by looking at what we've been talking about here, you've got the DNA coding here, and you've got the messenger RNA, and you've got the ribosomes making it. Once it's made, there's another machine that enters into or escorts it into a folding machine to get folded in exactly the right shape for a usable protein. And when you get it in the right shape, you're all set. Okay? You're all set. And by the way, this folding machine, according to the same TED Talk, this is Ken Hill, PhD, very highly qualified gentleman, by the way. I don't know where he stands on a whole bunch of things, but I would doubt that he's probably still a believer in evolution, even though he sees all this. But who knows? He folds it folds it, he says, so that the different amino acids are basically together. That's hard to do, isn't it? But that's what the folding machine does. And now we get to what this last letter is for. That is not redundant. It controls the timing and the degree of the folding to stipulate exactly what it's going to look like. So what we're seeing here is this is now a dual coding here, not just a single coding, when you get the degree of the folding, okay? All right, here's Frontiers in Genetics. You can go ahead and read this magazine article, Redundancy of Genetic Code Enables Translational Pausing, okay? Well, there's another DVD that was produced called The High-Tech Cell. That particular high-tech cell, Dr. Robert Carter, he called the DNA the most complex information storage mechanism in the known universe. Correct, isn't he? He definitely is correct, all right? He said the genome is a multi-dimensional operating system for an ultra-complex biological computer with built-in error correction, self-modification codes. There are multiple overlapping DNA codes, RNA codes, and structural codes. 22,000 or so protein coding genes combinatorially create several 100,000 distinct proteins. Okay, now it's just one layer of complexity here, isn't it? And then he started talking about that DNA is not one or two dimensional like we used to believe. It is actually four-dimensional. Four-dimensional. Now, first dimensional, you all know that. That's string of letters, right? String of letters. This is important to think about, that big long string of letters. What does it mean? If you look at it that way, you have no clue. But then you find out not only do you have the string of letters, but you also have the interaction network as well, working within that same strand of DNA. There's specificity factors, enhancers, how about switches, all this kind of stuff. All that stuff, that's your second dimension right here. In your third dimension, we have to think about the DNA being folded, don't we? Because if you have one strand of DNA, the thickness of a hair, it's a lot thinner than that, by the way, of course, but that one strand, it would be 30 miles long and all compacted into the size of a golf ball. That's a major feat right there. And by the way, in order to be able to fold it and put it in and compact it, you have to have several machines doing that. Molecular machines, okay? They're tiny, right? The third dimension then, actually, what Carter says, when God wrote out the information in the genome along that one-dimensional strand, he intentionally, at least Carter believes that, put things in a certain order so that they would be in the correct place when the DNA was folded into a three-dimensional shape. Okay, third dimensional. It's got to have a particular shape. The different pieces have to come together at the right spot. And, all right, and then the fourth dimension is time. And the time here is the shape. Well, it's the idea the genome dynamically reprograms itself. This is something we learned rather recently too. The shape, which is third dimension, interaction of the network, second dimension, and sequence of letters, the first dimension, all change. Oh, wait a minute, they all change. This is so far outstrips what Carter says, even our most modern computers, that the analogy of a computer here isn't even fair anymore. Interesting. Tremendous complexity. Many more layers of peeling the onion. And if you want to read that, look at it, look at the high-tech cell. You can actually find that on YouTube now too, okay? It's out there. So go find it, high-tech cell. So how did all this happen by accident? Well, roll the dice, right? No, not exactly, but there's a lot of faith that could all happen by accident. What's the probability of making one simple protein? If this is a protein of, say, 200 amino acids, you have proteins with 4,000 in the string. That's a bunch of them. Remember, they're specific. They do specific jobs. They're folded specifically, all that kind of stuff. But the chance is one chance, we figured it out, to get the correct lineup, one chance in 10 times 10, 260 times. It's kind of like hiding a blue marble in a universe full of red marbles, and then finding it accidentally 3 times in a row, blindfolded. Parnell, no fair praying about it. Okay? But basically, what we're looking at is not going to happen by accident. I don't think so. You got to take this DNA and make proteins, and a bunch of proteins to make DNA, and the whole system works together. So what's the answer to all of this in general? George Wald stated it in 1954, I believe, and we've had students saying the same argument ever since, given enough time. Time is, in fact, according to the George Wald, the hero of the plot. We have like 2 billion years to work with. Given so much time, the impossible becomes possible. The possible, probable, the probable, virtually certain. One has only to wait. Time itself performs the miracles. I calculated some of those probabilities and all the say, protons in the universe trying to get together, acting like amino acids, and I found out there's not enough time to even get started. So I found out that George Wald is off in his calculation by about 10 to the 39,000 power. About how far he's off with his assumptions there. Naturalism, the idea, how do they explain all this? Yeah, I like this one. This is Franklin Howard. We must concede that there are presently no detailed Darwinian accounts of the evolution of any biochemical or cellular systems, only a variety of wishful speculations. Okay, it hadn't gotten any better since 2001, by the way. But then, in the same breath, he says, we should reject, as a matter of principle, the substitution of intelligent design for the dialogue of chance and necessity. So what are they saying? We don't have an answer. We can't go there. Okay? Can't go there. I like what Lewontin said, who was a evolutionary biologist, wrote textbooks and all kinds of good books, popularized a lot of stuff. He says, we take the side of science. Now, first of all, he's using the word science. I say philosophy. We take the side of naturalism, the naturalistic philosophy of how we got here. This, in spite of patent absurdity of some of its construct, in spite of its failure to fulfill many of its extravagant promises of health and life, in spite of the tolerance of the scientific community for unsubstantiated just-so stories, we can imagine. Because we have a prior commitment to materialism. That's naturalism, okay? It is not that the methods and institutions of science compel us to accept material explanations of the phenomenal world, but, on the contrary, that we are forced by our a priori adherence to material causes to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive, no matter how mystifying to the uninitiated. Moreover, that the materialism is an absolute, for we cannot allow a divine foot in the door. Okay? Dr. Scott Todd, another one saying about the same thing. Even if all the data point to an intelligent designer, such an hypothesis is excluded from science because it is not naturalistic. I will agree to some extent that we don't want to just come up and say, oh, that's because God did it. All right? Lightning, oh yeah, God's out there throwing lightning bolts down, right? Now, we need to look for natural causes, but what if the data is actually showing that, oh my goodness, natural causes fall short of explaining so much of that? Then I think that we as students and teachers need to be able to go to the point and say, yeah, it looks like a designer made all this. I think that would be the realistic thing to do. But in light of all these things, keep in mind naturalism. And evolutionary is a pillar of naturalism. Is not really science. It's a philosophy. Posing as science, the belief system that everything can be explained by naturalistic process. Okay? And that is naturalism right there. I talked about the probability of a protein. An atheist and an agnostic calculated the probability of a cell. They said it was 1 chance of 10 times itself, 40,000 times. That's hard to come up with, isn't it? I've seen other ways that show about the same order of magnitude. Dr. Hoyle actually stated it this way. He was one of the two that I just mentioned. He compares the chance of accidentally producing a cell with that of a tornado, sweeping through a junkyard and producing that Boeing 747 airplane. They then said there must be a God, quoted in the newspaper, Seattle Times. Interesting. They didn't run out and buy a Bible to find out about that God. Farnell, no. They said in the article, we are still looking for a way around our conclusions. Why? Even if all the data is staring them in the face, they're committed to naturalism. And we have been taught almost exclusively naturalism, haven't we? We really have. There's so many articles out there that it's now go right in the face of naturalism, you might say, saying, whoa, you're not going to explain those things. I think it's a great day to be a Bible-believing creationist. Okay? I'm going to take it one step further. It's a great day to find out who that creator is. It really is. And don't just stop. Oh, there's got to be a designer. There's got to be a creator. Find out who that creator is. And when you look at it, you look all over this world, you see what? Clues. Great clues that God is a great artist. Great artist, and he loves beauty, doesn't he? Okay? And it's not only the flowers, but all of creation. It could have been a black and white world. We said last night that beauty does not necessarily mean it's a mating advantage. Okay? Well, we said that Wednesday night. In fact, they're finding out that the splendid peacocks did not win the attention of the females, by the way. Okay? And so, is it a mating advantage? Not necessarily. Okay? To me, it looks like everything I see, even from a droplet of water, I see tremendous design. It tells me, it looks like there's a designer there who is interested in details. So therefore, he's interested in the details of my life. I have to acknowledge that. And I even look deeper, and I look at the DNA, and I look at molecular machines even working within the cell, and based on molecules powered by protons, and I see there's intricate details, another level of the onion to peel, okay? Then I look at the size of the universe, look at the beauty out there, look at the design out there. I see we have a powerful creator God. Powerful creator God. In fact, that's what it says in the Bible. God numbers the stars, calls them all by name. Isn't that a neat verse? Power of God. But what I like about it, and I hope we can all recognize this too, God is all powerful, but he doesn't stop just with power. If he was all power, we're all in trouble. Okay? We are. But the verse right next to that in Psalms is, he heals the brokenhearted and binds up all our wounds. That's a God who cares and has power to do something. And that's the kind of God that I want to serve. Okay? And that's what the biblical account, that's what the biblical record shows, that this is our God. I see the evidence crying out things were created with design. So Mary Jo's going to come down. We're going to open this up to some questions. Okay, go ahead, Parnell, give us some instruction on that.
All right, thanks Dave for the great presentation. Hour and 15 minutes, huh?
All right.
I told you Dave was long-winded.
I know it, I'm sorry, I'm so excited about this stuff.
It was all good. So appreciate that. So we want to open it up for Q&A, and what we want to do is ask that you ask a question. So if you raise your hand that you have a question to ask, and that you limit the comments and just focus on the question. And then what we want to ask is that we want to give you an opportunity for a follow-up question, and then we want to give other people a chance to ask questions as well and move around the room. And if there's no more questions and someone wants to continue a dialogue who has already started with, say, a question and follow-up, then we can go there. And before we get into that, I just want to say the Q&A session time depends upon how productive it is and how long we have questions and things like that. We do have the room for some time yet if we'd like to have the formal Q&A go on for a while, and also we may end the formal Q&A and go into informal Q&A where we can continue dialogue if that's going to be desired as well. One last thing, we have Maranatha Christian Fellowship, who sponsored this event, has another presentation tomorrow night. That is at our campus church. There's flyers and materials on the back table. The worship service is from 7 to 9, and we're going to talk about how you can believe the whole Bible. And did God use evolution, or is Genesis just poetry? Those are some of the primary questions we're going to address in that presentation. And that's going to roughly start around 7:50 and go till about 9. So before that, we have praise and worship. You're welcome to come, even if you're not Christian. And if you weren't welcome, we wouldn't be Christian. So you're welcome to that. So with that, we'll get it started. Any questions out there? All right. So this gentleman here in red, why don't you go ahead?
You didn't give a definition of design. How do you tell if something's designed? Like if you find a watch on a beach, what is it about the watch that tells you it's designed?
I see organizational structure, I see function, and design and function go hand in hand. Like the dorsal fin. Oh, I see the, like on the dorsal fin, I see function and design going hand in hand for the cooling of the creature. I see cascade systems, which indicate to be design. I see evidence of design in things that we know specifically are so well designed, okay, that that any engineer basically would look at that and say, ooh, I'm not sure I could even duplicate it. So I see that's part of what I might look at as evidence of design. Beauty is one of them, by the way, but that is not the overriding one. Okay, go ahead.
A specific function,
Yeah.
which is imposed upon the molecules and the chemicals themselves. In other words, they don't just naturally fall into those functions. That they have information that's there, but it's imposed upon it. It's like taking some ink and throwing it on the wall. Yeah, you can throw ink on the wall, but it doesn't contain information as far as being able to transmit information. And so information in systems that have that kind of information in them would be another indicator.
Another question.
Geological.
Oh, you follow up on that? Go ahead.
Yeah. So if there was a non-designed object, because I believe you think everything's designed, the whole universe is designed by God, so doesn't that mean it all has a purpose? And if there was something that wasn't designed, how would you identify it?
There is randomness also.
Yeah.
I mean, we're not saying everything is designed. There are random processes, obviously. If a tornado goes through a junkyard, then you're left with a pile of stuff that's, you don't say that has a design. That was something that was formed obviously by a natural process, a tornado sweeping through a junkyard, and you end up with a pile of stuff, but it has no form and function that can do anything. If you see that tornado go through and produce an airplane, that would be, you go, that's impossible. And yet, that would be indicative of design, but just to pile it up according to the way that molecules would normally pile up is not necessarily design. We had somebody over here, second.
Somebody here next. Yeah.
Well, I want to propose an alternative hypothesis, and hopefully through this we can help to understand where we might disagree. When I have been listening to your argument, I interpret it as something like there is this thing which we call like an emergent phenomenon, which is like that ATP synthase you spoke of, or any of these numerous amounts of crazy, incredible biological phenomena that seem to be so specific and so functional that they couldn't possibly be random. Am I correct in that interpretation?
Did you hear what you said?
Not quite.
That
Okay. Yeah, he's saying that you were showing so much complexity that you're saying it couldn't possibly be designed. Is that?
That's what somebody has actually stated.
Is that what you're?
It's too many levels of complexity. There can't be a God that powerful to create it.
Would you say that is an accurate interpretation of your argument?
No.
No. Why not?
I believe things are too complex for them to happen by an accident.
That's not what he's, yeah.
There must be a designer, so I may be misunderstanding. Why don't you go ahead and answer if you have a better understanding of what he's saying.
Yeah, it's not just complexity, but it's the type of complexity, it's the organizational structures, the interrelationships of parts, not just complexity.
Like the 20,000 machines, yeah, they're so highly complex. You say, an engineer can't even make one like that right now. We can make a big one, and there are more of these machines in the end of your finger than there are entire electric motors and gasoline engines around the entire world, okay? And so I look at that, I say, those machines look highly designed, okay? And to me, and that's just seeing how they work. Seeing how they work and try to figure out how you might be able to even come up with a model of some of that stuff, especially on that scale. It's going to be tough.
Well, in response, I would say that I see the argument against randomness, and I think you're correct in saying that we perhaps don't have enough evidence in claiming that these immense processes are completely the result of random interaction, as you put it. But
They're not.
Is it possible that the way we're interpreting these phenomena is not a result of what physically is happening, but maybe the way in which we're interpreting it, so that perhaps that our interaction with what's physically happening is unique from what's physically happening. Well, this is a useful and interesting phenomenon, but maybe that's more reflective of how we view the world as opposed to how the world physically is. What do you think of that?
That's more of a philosophical question, isn't it?
It is.
I think it is. I mean, it's how do we interpret the world around us, and the ordinary way in which we interpret normal things in the world. Where if we see a building, we don't think it happened by natural processes, just chance. We recognize human intelligence designed and built that building, and so we recognize design at that level. But then, you know, a lot of people are unwilling to recognize design at a higher level when it comes to biological systems. And so, yes, there's an interpretation involved. And some people will interpret that complexity and apparent design. Some people will interpret that as a result of naturalistic combinations of molecules. Others will interpret it as evidence of an intelligent designer. But if you already rule out an intelligent designer, then you're not going to be able to see it anywhere because you've already ruled it out. It would be as if you ruled out any kind of human builder. If that was already ruled out, you would have to come up with some way to explain this structure because it actually exists. But if we said, well, there can't be any human being that is intelligent enough to create this building, well, then we'd have to come up with some naturalistic explanation of it, if we wanted to try to explain it at all. And so it really comes back to, you know, are we willing to recognize that there could be an intelligent designer, or are we constraining ourselves only to naturalistic processes? Okay?
Kind of based on what we can see, what we do know, it sure looks designed. For me, I would say it would kind of taxes credulity to think it could have happened by accident, actually. It just, I look at that and say there's no other conclusion I can make, okay, than what I see is design.
Okay, you next, Josh?
Yeah, so are you guys familiar with the argument from ignorance or personal incredulity fallacies?
Say it again?
The argument from ignorance or the argument from personal incredulity?
The argument from ignorance.
Yeah, like logical fallacies.
What you said?
Explain it a little bit.
Sure, so the, I guess if I were to make an argument from ignorance, say we have a situation in which I don't know, like say we have someone who's murdered, right? And I don't know how that person was murdered. And the only conclusion, I guess, from just looking at the situation is that I can come to is I don't know how that person was murdered. And if I were to make an argument from ignorance fallacy, I would say, well, I don't know how they were murdered, but I'm going to assert this anyway, right? And so I see lots of parallels between that situation and what you guys are saying. So we have maybe a situation that or a system that we don't know how to explain, right? So we have incredibly complex proteins in the body, right? And we say, okay, maybe we don't have an explanation for that, right? But I guess why do you then go to assert that we do in fact have an explanation?
It again comes down to your primary assumption of naturalism or no naturalism. If you believe in naturalism, you're saying the same thing. Basically, you're saying that somehow you believe it all came about through naturalistic processes. You might not know how. I mean, I might not know how this creator did this, but I can still point to evidence of a creator where somebody else might point to evidence of but it had to have happened naturalistically. And I don't see the difference in that. I believe that they're equivalent jumps from the observation. You can agree upon the observation, but then from there, if you go into the realm of how did it get there, you either take the idea that there can be a supernatural, or you take the idea, no, it had to be natural. And so either way, you are outside of the realm of empirical, refutable, testable science. Either way.
All right. Well, I guess I would say that I don't, given the situation in which I don't know the cause of it, I wouldn't a priori exclude supernatural causes necessarily. I just think that in order for something to be credibly asserted to have a supernatural cause, that has to be demonstrated, right? That claim has to be demonstrated. And I don't see how what you guys are saying is really like any different credibility-wise from saying maybe like a pixie, right, created life, or a leprechaun, right? And I'm not saying that to be offensive. I'm just saying that those are equivalent leaps in our conclusions, right?
You also need to realize, though, that science isn't the only way in which to arrive at truth or to arrive at an explanation. History is another. Historical evidence is another. Historical documentation. And so, it's a different kind of science. It's a kind of science that's more like forensics, where you're building based on the evidence you do see, and you're never going to arrive at it 100%. You're not going to be able to say 100%. We couldn't prove 100% that there is an intelligent designer, just like you couldn't prove 100% that it came about by natural processes. But a lot of students tell us, well, they're atheistic, or at least they're pretty convinced that there is no God. They have already made that judgment that they haven't seen enough evidence. We say we have seen enough evidence that there is a supernatural that interacts with this world of natural substances. We believe that the Bible is historically accurate, and over and again, archaeologically, and through other ways, you can document it. And so there are other lines of reasoning in addition to science line of reasoning. And I think anytime again, just the analogies of saying we can't get a building, a building implies a builder. Every house is built by someone, you know, and likewise, when we look at this universe, and when we look at the cells in our body and the biochemical processes in our body, it is much more phenomenally organized than this building.
Yeah.
And yet if we came in here and said to you, this building just happened because concrete molecules have a tendency to get together, you know, and they're gonna, given enough time, they're gonna bounce around until finally they come into this shape, and we get light bulbs and we get everything else. You'd say we're crazy.
Yeah.
And yet when it comes to the biological systems, which are phenomenally more complex than this simple building, you know, people are willing to say, no, it just came about by molecules bouncing around, coming into contact with one.
Wait a minute, you can't do that.
Hold on.
You keep doing this over and over again.
Hold on.
You say it's complex, therefore it's designed.
No.
This is a false equation, and you've done it for the last 2 hours.
Hold on.
Statement here.
I'm a little tired of the bullshit.
E.Z. Myers, please ask a question. Phrase it for a question when you get your
Okay?
And again, we said it's not simply complexity that we're talking about, it's the ordered complexity, it's the combination
Which
of,
can be generated by natural processes.
combination of chemicals operating together, operating in complex systems, like machines, like language systems. There's nobody in here that thinks that a computer just comes about by accident. It's a complex machine that carries language. DNA is a complex machine that carries language. And it's a matter of faith at that point. You know, we don't believe these things came about by accident, but just because we can't see the origin of life, all of a sudden, you know, then we can say, oh, it came about by accident. We have a different worldview. We have a different way of viewing what came about previously, right? We can look at systems, we can look at the complexity, we can look at the interrelationships parts. We can see that. That's observable. How it got there is a matter of faith, isn't it?
Before we have this question, we have
Did
two
you have a
others that
question,
had their
Lisa?
hands up earlier. You and you, right? In the yellow. All right. Did you have one? Oh, somebody's next to you. Oh, go ahead.
What about the duds? Like, what about the species that are no longer existent? The ones that failed? The ones that simply were not designed well enough, if they were designed? Does that imply a flaw with the creator? Or is that just something that can be explained? Because if they're capable of producing wonderful systems like the Geological's radial systems, then why couldn't everything also succeed? Why would there also be failed designs?
Okay, failed designs in the current environmental system, I think we have to say. The biblical account of creation talks about creation, yes, but it also talks about the introduction of death and disease and deterioration, and mutations can result. Disease is true. Many things can't adapt, perhaps, to new environments and so on, and then they go extinct. We see the record of much extinction in the fossils, don't we? But we would interpret that a little differently. It's not failed designs on the way of moving up the scale of evolution. It's creatures that died in the flood event, in a watery, catastrophic event, and then after the flood event, that the environment was so different than it was before that many of these things could not survive. And so we see deterioration. Like John Sanford points out in genetic entropy, we do see that. We see the buildup of genetic mutations. Okay?
And brief follow-up question. So you posed that like the flood fundamentally altered the situation where these organisms were living, so they were no longer designed for that way. But given that a flood occurred, how would I'm not exactly sure that kangaroos can swim all the way to Australia. And why wouldn't we find them across a different geographical spread?
We talked about that last night, answered that question last night, the idea of how do the animals kangaroos get to Australia. That's usually the example that's given, okay? And a couple of ways that it might be is if we propose that there was an ice age, and I think that's pretty clear from Geological. Yeah, we agree there's an ice age. Lots and lots of water in the ice would have lowered the sea levels and leaving land bridges between the continents. And
Huge
so,
ones, by the way.
perhaps they hopped. Another explanation is they could have been taken there by human beings.
Proliferated.
We see that happening also, is where human beings have transported animals to various places, and they proliferate from there. You can do population studies, by the way, that show that the numbers that you will find fit well within that time frame since the biblical flood, and you can do those calculations.
And they're pretty well illustrated in that book
Replacing Darwin. That book has a good chapter on
book.
biogeography, if any of you are real interested in that.
I think it's important to emphasize in your explanation that giving a little more detail, unless I missed it.
Mm-hmm.
So in the migration patterns that are proposed by at least one creationist or some creationists that you're referring to, after the flood, the events of the conditions, the warm ocean, and how there were these land bridges. Are you saying they hopped on ice caps, or is there more to it? That's a misconception.
Oh, okay. Yeah. No, the ice during the ice age would have been very, very thick in certain areas in the northern continents and so on, lowering because of the water that was contained in the ice caps, and not only the caps, but in the interior of those continents, such that the water levels of the ocean were lower. So there would have been land bridges, like across the Bering Strait, for example. And I believe there was one that you can demonstrate going to Australia. We'd have to look at that.
Yes.
I'm not an expert in biogeography, but I know I can point you to some resources if you want.
And not only do you have in the ice caps too, but you also have mountain actual building that's going on and huge land masses coming up. That would also put a lot of water up in inland seas, etc. So you've got inland seas, you've got the ice melting, you're going to fill up those things, and eventually they're going to overtop and then spill out, forming a lot of canyons as well. But when you look at all that water that she's talking about in ice and also in inland seas, you look at the continental shelf, you find big canyons clear out hundreds of miles onto the continental shelf, and you recognize, wait a minute, this was above water level at one time. When you actually look at that, you see that off the coast of San Diego, you see it in the Bering Strait, you see it even in Australia, etc. I did some calculations a number of years ago. I was actually teaching a course in wildlife calculus, basically for biologists, specifically for wildlife majors at that point. Interesting class. And we looked, I did some studying on some of the distributions, like for instance the kaibab deer here and things like that. And I looked at some of the known migrational rates based upon examples, and I said, wait a minute, it looks as though within 400 years you get pretty much the distribution we see with not only the major animals but even the minor animals too. And the book Replacing Darwin's actually puts a lot more numbers to it and basically shows the feasibility of that. Okay, Replacing Darwin, a 2018 publication by the molecular biologist, cell biologist from Harvard.
So I think we have a question.
Yeah. So maybe God did design all this stuff, but maybe it was caused by an unknown natural
I give all the hard questions.
Well, why would we prioritize the supernatural over the natural? Well, I think for one thing, and again using the analogy of a building or a watch or whatever, the supernatural seems to us to make more sense than the natural. That would be one thing.
Why would you not accept
Is
a...
design a natural thing? Because design is a natural thing, isn't it? So how do we make it supernatural?
Design is, intelligence is needed for design is what we're saying. And we're looking at what is the source of the intelligence in this universe? You know, either, I mean, I suppose you could propose a natural being that is natural, a human being, like a creature that is bigger than this universe. You could propose that. We have no evidence, you know, again, so we would take the supernatural over the natural in this case just because it seems to make more sense to us. You're going to end up believing something, okay? And maybe there is a natural cause of the whole universe we know nothing about. That would be a possibility. Yeah.
So my question was, if there is there could be a natural cause to the universe that can't explain everything, including the current design, why would you prioritize the supernatural? Because the natural without intelligence could explain it. Why would we need a supernatural with or without intelligence?
No, I wasn't saying the natural without intelligence.
I'm saying that.
Okay, you're just saying the natural without intelligence could explain everything?
I don't think so.
Yeah, there could be unknown ways.
There could be. But then that comes down to each individual. What are you willing to accept?
That's why I'm asking you, why do you
Yep.
prioritize the supernatural over
Okay.
the possibility?
We would prioritize the supernatural there because we believe that we can have an experience with the supernatural, with God. And we know that through the Bible. We know that through personal experience. It's not something we can prove to you. It's a matter of faith. Just like if you believe it all came about naturalistically, it's a matter of faith. And so it's a faith decision in one case or the other. For ourselves personally, we believe that it makes more sense, more logical sense to believe that there is a supernatural being with intelligence that has created us and created the universe. And I'll agree with you, it's a faith thing, but we also believe in what the biblical account says, and we believe it because of personal experience. We do believe and we have experience that you can be in a relationship with this supernatural God.
For me, I see natural, and I see some things that I don't believe the natural can explain by itself without intelligence. And that intelligence, I can't go on with the idea that the universe is a mind that gives us all this stuff. I believe the God, that there is a supernatural being that is a whole lot smarter than we are, that basically must have put this thing together. That's my conclusion. I see natural, but I also see what I say, it looks like design, looks like supernatural. All right, there's this question here, and then it'll be fair to go to Dr. Meyer, back there, and then yours again, okay? And your three.
Okay, you brought up that really cool example of the slug that eats its prey and then steals its poison missiles.
Yeah.
It's like that really integrated, complex system of kind of pirating it. Do you think that was designed before or after the fall?
That's a good question. That's a good question. And you wonder what was the benefit of it before the fall? And we do recognize the element of the fall that did make it a dog-eat-dog, dinosaur-eat-everything else world, right? And so we do see that there are some things there that all of a sudden there are storms and thistles, etc. If you accept the biblical model, okay? And I believe when you look at great design, you can't divorce it from the possibility that there was a fall. And it's the fall that we all worry about because that's caused horrible consequences on earth, and that's why Jesus Christ had to come and die. Okay? But so, what is the sequence? What was actually used? Was it used before the fall? Hard to tell.
Yeah, we really don't know if it came first or
It's one of
second.
those questions.
I speculate, this is speculation, okay? I speculate that God in his wisdom, he gave Adam and Eve a choice, didn't he? You can eat this or you can eat this. He gave them a real choice, a real free will choice. And it's kind of like a computer system. If this, then down this way. If this, then down this way, right? And I think it sets into motion that choice, sets into motion other characteristics that are going to take place. But we can't prove that to you.
Number 2 was P.Z. Myers. Yes.
Okay, so over and over tonight, the phrase I have heard is, "It sure looks like design to me."
I would have to say
That, however, design is the assertion we're trying to test. You can't simply say, "It looks like it to me," and wave away all the problems. Then, as evidence, what we hear over and over again is, oh, here's a system, it's really complicated, it's functional. But there's no connection between those two. You falsely equated function and design. And I'm saying that there are alternative mechanisms that are entirely natural to explain that. Now, earlier, Mary Jo mentioned, and Mary Jo, I don't need you to give me more flowery language about function and complexity. That doesn't change the fact. But earlier you did say something that was quite sensible, and that is what you rely on is alternative lines of evidence. That, for instance, what we do in evolutionary biology is look at ancestral states, we do comparative biology, we look at the molecular evidence behind it, we try to determine the actual process that gave rise to this so-called design. Now, we can talk about all kinds of evidence and all kinds of empirical evidence for these processes, which I notice you neatly just glided right over and claimed that it was just scientists saying, we imagine this. That's dishonest and misleading. What you haven't done even once tonight, yes, so what you haven't done even once tonight is answer this question: where is the evidence for design? And if you fall back on, oh, it looks complicated and functional, I will puke on the seat in front of me. So don't do that. Give me some independent line of evidence that shows that we're looking at some kind of design.
Let's give him a bag, should we?
Give him a bag.
So you're admitting you have nothing. You have nothing other than your assertion of the supernatural.
No, it's not nothing. It's not nothing. And I would ask you then, you are proclaiming that it all came about by naturalistic means. Right. Where's the evidence for that for everyone?
Open a book.
We've opened books.
No, you haven't. You apparently haven't understood it.
Yes,
but
we have.
no, there's plenty of evidence for natural processes that generate increasing complexity in modern populations, for instance.
Because we've already got life in existence, and because we already have complex bio.
But then what you also do something else dishonest when you claim that all these other processes arise by chance. Pure chance has never been an argument for evolution.
Only chance on mutations. Then what has produced that, and then you
chance, natural selection, all kinds of processes.
I'm not saying it's all chance. Mutations coupled with natural selection. That's the buzzword.
Then why do you ignore natural selection in your explanations?
We don't.
I don't.
We don't.
You did tonight.
Natural selection can select, but it can only select from what's already there. So if you follow it back far enough, and you get back where, natural selection can only select from what's already there. Mutation can only act on what's already there. So you've got to start with something in order to have mutation, and you've got to start with something to select something. And
you can go back to chemistry.
It doesn't explain where did the chemistry come from.
That's not part of evolution. We don't.
Yes, it is. I mean, I'll ask you.
A part of naturalism.
It's a part of naturalism. Okay. There are different definitions, yes, of evolution. Are we talking, are we talking simply, we got into this the other night, are we talking changes in the frequency of the alleles? Are we talking about the evidence that things like fish could change into amphibians? At what level are we talking? When you say evolution, what do you mean by it?
I'm talking about all of those levels.
You're talking
Macroevolutionary
about
processes, microevolutionary processes, genetic variation, all these things are real.
Fish the philosopher. Yeah.
That's where we would have to say we don't see that evidence.
Because you don't look.
You don't see the evidence for creators.
You haven't presented it. This is what I would have expected you to do tonight, is present the evidence for a designer. You haven't got any.
What would you accept?
You're the one telling me.
What would you
And
accept?
when you tell me complexity and function, that is not evidence for a designer.
We're talking ordered.
You're doing it again. You're just throwing other phrases at it. It's the same thing.
Like a language system. The DNA, a language system.
This is why I hate arguing with creationists.
Well, we don't want to argue with you anyway. We're not here to argue.
Yeah, nothing's going to change your mind. So.
Well, it won't
Yeah.
change yours either.
Oh, evidence would. Got any?
Are you committed to naturalism?
We just want to say thank you so much for coming. We hope you'll stay further. We do agree that microevolution is something that
Oh,
we can
God.
observe, and so we're not disputing that the process of microevolution exists, but it's the extrapolation beyond that we do dispute macroevolution and evolution. But maybe we'll get around to it with another exchange. We're going to give another couple people a chance to ask some questions. Well, this gentleman here in the gray coat.
I would just like to take a moment to acknowledge the fact that you, in an unpopular belief, are coming to a place that seems to be opposed to what you believe. I appreciate that you are strong in what you think to be true and are willing to host a dialogue like this. I think it's rare, and I think it takes a certainty when you believe, and I respect that, even though I disagree with you. Now, what I would like to ask you is, it seems as though your position publicly is becoming less popular. Why do you think that is? Because I'm not sure I understand it like you might.
Well, let me ask this question. What is normally taught at this university? Do you ever hear anything besides naturalism? Most every high school around the world, what do you hear? Naturalism. Okay. We are also told separation of church and state. You can't even mention the possibility even of a designer, because designer means, or design means designer. Can't even mention design. Therefore, that's not naturalistic, and we can't go there. Separation of church and state. That's what Scott Todd was arguing when he said even if all the data point to an intelligent designer, it's excluded. Okay, we can't have it. So what would be the natural result of that? Over years and years of that kind of education, of course there's going to be only naturalism taught, only evolution basically taught, and you wouldn't hear anything else. So that would answer your question there. It's just a natural thing of what's going on in this society. Not necessarily because we have all the evidence to prove naturalism. Not at all. It's because that's all they're taught. It's just like all I was taught was evolution when I was young too. So I ended up believing it thoroughly until I started looking into some of the evidence, and I said, no way, I don't see how evolution is going to produce these systems. Okay? That's what I had to do.
I think a lot of sarcasm, a lot of mockery, a lot of pressure, a lot of shame comes against the creation movement. So people are embarrassed to come to a presentation, right? And when we promote this presentation, we encounter a lot of resistance. Passing out flyers, people cuss at us. People yell at us, call us a-holes and things like that. We're just being nice, saying, how you doing? Here's a flyer, come, and people tear down our posters. People steal our signs or promoting that out here. You get a lot of resistance, and so I think a lot of people aren't open to creationism because of public shame. I don't think it's necessarily an intelligent reason. I think it's just a
If this is the quality of the evidence that's going to be presented for creationism, you should be ashamed.
Please wait your turn.
No, I'd just like to restate that. I appreciate we can have this dialogue.
Thank you.
Thank you,
And
yes.
keep in mind that both of us used to believe in evolution, and we ended up realizing there were some problems with it. Okay, I think this question.
One of the other factors that I would just say along with that, though, is that you know, when creationists have a different interpretation of the evidence,
Oh, God.
oftentimes it's laughed out of the publications and so on. And so you can't even get things published if you have a different interpretation, no matter how good your research is. We're more communicators and educators. We're not doing the primary research, but we're looking at the research that others are doing. And what there are people in the creation science movement, very well qualified. They're doing initial research, and yet they don't get the grants. They don't get they don't get the publishing usually if they're known to be a creationist. We know people individually that have been fired from their jobs for teaching, for believing in creation, even if they didn't teach it in the classroom, just because they believe it.
Yeah.
And we're going, wait a minute, that is not a fair and open academic environment. And so we don't have an issue with, like he was saying, with the microevolutionary changes. We agree those things take place. It's extrapolating from those things that we believe is a philosophical argument, not direct observational science. And so we're on that level, we can do the same research, but then we come up with different interpretations. And it's in the interpretation of the evidence that the disagreement comes in.
You said the reason you believe in the supernatural is because of the Bible and your personal experience. And the reason I believe in the naturalism is because of the inductive evidence provided by numerous natural scientists. So do you think that the Bible and the personal experience is comparable to all the different natural sciences that we have in society?
Well, part of the natural sciences, of course, we would go right along with as well. So yeah, there's a lot of stuff there from natural sciences.
Not ruling out empirical investigation.
Not against science, empirical investigation at all.
Not ruling that out.
And we like to do that. But if the evidence leads to potential of a designer, then I want to be able to go there. And I think students should be allowed to do so too. All right,
and again, the difference is what is actual empirical observation and what is a jump of logic from there or a jump of
extrapolation. Watch out for extrapolation as well. Okay, I think yours and then yours. Oh, you follow up to that? Go ahead.
I didn't quite understand that. So my question was, your basis to believe in the supernatural is the Bible and your personal experience, what you said in the last question. And my basis is all the natural sciences indicates natural stuff. So it would be reasonable to inductively conclude that things we currently don't know are probably going to be natural, just like all of this other stuff we discover is natural. So why is it reasonable for you to believe that it's supernatural if all you have is the Bible and your spirit?
Naturalism.
I didn't say that's all, okay?
No, it's not all.
We're looking at what we can see and what we do know about this world, okay? And we're comparing it to what people have made about what the qualities of designed systems are.
Evidence of supernatural is designed to be natural.
Just a second. What I'm seeing here is, I look at the natural world, okay, and I see all kinds of stuff, all kinds of things. And when I look at it and try to make sense out of it, you might say, I see that there's way too much that indicate there must be a designer behind some of this, okay? Now,
in other words, you say
what
what sure looks like design to me.
I can either let it lie right there, or I wonder, who is that designer? That's the next step, and that's where you might get into the biblical aspect of it. Some people will see design, they don't have any idea of biblical faith or anything like that, or any kind of religion whatsoever, but they've been seeing design. And they recognize there must be an intelligent designer. And then from there, some of them then will look at who is that designer. So your natural world could come up with conclusions that there is a designer. Okay? Now, who is that designer? Well, I think we have a pretty good answer with the biblical record. To me, it satisfies. And it aligns with personal experience as well with that. But you can come at it directly, strictly, from looking at the sciences or the philosophies, and eventually seeing so much, and then come to the realization there's got to be something more. Got to be something more than strictly only natural processes.
If we look at a book, we see ink on a page. We could go into the lab, we can study that ink, we can look at all the characteristics, all the chemical and physical characteristics of ink, we can study the chemical characteristics of paper. None of that will tell us how did we get the information that we see. We know it took intelligence to get that information. Now, if you're proposing an intelligent source that you claim is natural versus supernatural, you know, they're at that level. We're still operating in faith, aren't we?
Okay, I think that question and then yours, okay? And then back to you, okay? Go ahead, Josh. Did we have the wrong order?
I haven't asked a question yet, so get me back to me.
Oh, I'm sorry. So go ahead, you figure out who goes.
Okay. Now, go ahead.
So, and I've asked this question before, and just in case there are people here who haven't heard this, science doesn't work exactly the way that you present it, where it's just a collection of facts and then it's open to interpretation, and then we go and collect new facts and make new interpretations. We get some data, we make some observations, and then we generate hypotheses or interpret, whatever word you want to use. And then that's a stepping stone for the next set of experiments. And I'm a little annoyed at kind of an hour and 15 minutes of a lot of hardworking scientists did a lot of work and thought a lot and came up with hypotheses and tested stuff that you put up there and giggled about as how could anything. It was based on a lot of foundational information that you kind of started at the end point and said, well, here's just the fact. But that was based on more stuff. And I asked this on Tuesday, I guess, that is this kind of like looking at data or looking at facts and then trying to work it into your worldview after the fact, is that the way you see science as being done? Because it's not the way I understand science is done.
The data that's coming about that was referred to tonight, yeah, it's coming out by processes of studying this world and trying to understand how it operates. Physical properties, how does it operate? Where does it, you know, how is it, what are we seeing in the DNA? What are we seeing in the RNA and so on? That does not say how it got there, though. It doesn't say how that information came about in the first place. So we recognize the process of science, and we recognize it's a very powerful process in learning to understand this physical world we live in. But it doesn't tell us necessarily how it got there.
But we can ask that question. So here's the issue, my follow-up question. Here's the issue. Once you invoke supernatural, you've essentially killed the ability to ask a question. Yeah, absolutely, because if God did it, we're done. Because God is omniscient and can do anything and miracles happen. So there's no point in asking any questions because we're done. And the question that this gentleman asked at the very beginning about isn't everything designed in the universe? And the answer you gave him was the tornado in a junkyard. How do you know, how can you, based on your worldview and how you're talking about how organisms evolve, how can you prove to me that all the junk in the junkyard didn't land in what you're saying is totally natural. Didn't land that way because it was designed to land that way.
I think one of the things they did was demonstrate mathematically the probability being basically zero. And that's one argument, you know, and it's an intelligent argument using mathematics.
We could use mathematics to say if we put 10,000 pieces of junk in a junkyard and put a tornado through it and it randomly ended up spaces, what are the odds of each piece of junk landing exactly where it did? The number would basically be zero. So by that approach, we have the exact same argument that that tornado intelligently designed that garbage heap.
But that junk in the junkyard does not have any semblance of a organizational design.
Sure it does. You just don't understand it yet because it's supernatural. Because that's what you're saying about us. It's like these organisms are designed and so special, and God did it, and we can't possibly understand it. I mean, the way you present this stuff is essentially don't ask any more questions.
I wouldn't say that's true. Yeah, we're in line with the early scientists who saw, as they looked at the world, they believed, yes, there's a creator. Their human curiosity and desire to know caused them to do the research, to learn more about this world. And in the same way, creationists who are scientists, they're studying this world to get to know more about this world. And so it's not a killer of science. A belief in the supernatural is not a killer of science. In fact, we know scientists, we've read about scientists in the past who have gone into the lab specifically to find out more about this world. They had the creationist viewpoint, but that didn't kill science for them. I mean, if you believe in naturalism or you believe in a supernatural, it still does not kill the idea of we want to understand this world and how does it work. And
I don't think you know what supernatural means.
Huh?
I don't think you know what supernatural means, because if the supernatural is true, and that can be our answer, then anything, so I can do a study and show this leads to this, and you or anybody could argue, no, it's not that. It just looks that way. It's the devil buried fossils to trick us. That is a supernatural explanation of the fossil record. That's a supernatural, but that's a supernatural.
And yes, it has been used by some people.
But that's a supernatural explanation, and
yeah,
we wouldn't support that argument.
Why not? How do you rule it out?
I think as a scientist who believes in a creator God, I still have curiosity. And it's the curiosity that drives somebody to find out, wow, I wonder how much more we can learn from this. So as a scientist, no, it doesn't stop it. It makes me look for more. And that's why I get excited about this kind of information. I'm looking for more. I'm not saying, oh, it just happened by natural process. We just don't know how it happened. So, but maybe someday they'll figure it out.
We certainly don't propose to suppress naturalism, you know, as a pursuit of origins in science. That's not a proposal. What our proposal is to persuade people to our viewpoint, to have a scientific discussion, and it's a discussion based on origins and philosophy and religion. And we would respect people's freedom of conscience, freedom of inquiry to go and pursue naturalism. We just want access to the students' minds, you know, to be able to try to explain them.
Why to them?
Be able to get them to think. Now, who's next on that?
Sounds good.
Yeah, I was going to address the thing that Frank mentioned about the, I guess you guys talked about the improbability of biological systems rising purely by chance, and I just think it kind of demonstrates that you don't necessarily understand how, under an evolutionary worldview, living things come to be. So we don't say that they simply can be by chance. We talked about this earlier. So basically, any sufficiently complex system, if you were to determine the probability of its existence based on the model, or based on the methods that you use to of a living thing existing.
Josh, can you speak up?
Sure. So basically, if you have a okay.
Well, that's okay. I'm going to have her answer the question.
So if you have a sufficiently complex system,
I'll figure out what you said as she answers it.
It's basically improbable, right? But that's fine because the world doesn't operate based on random chance. It operates based on natural laws, which are very predictable, and we can investigate those laws. And biology and DNA, they don't operate based on chance, right? The folding of a protein doesn't operate based on chance. It operates on natural laws, which we can predict and model relatively well in order to get, can create predictive models, which can demonstrate how these things work. So this isn't random chance, and I don't understand why you keep going back to the idea that it is. So why do you keep doing that?
Would you think that the protein that was folded was only following natural laws when it got bent and twisted and shaped into exactly the right shape so that it could work inside of a motor of 32 proteins and work in unison? Or is that shape where it put all of the, basically put the different types of amino acids together, whatever? To me, that is not natural laws that's going to do that. This is a folding machine.
It's not going against natural laws. It's not going against the laws of chemistry and physics when it does that. Just like to have a book, you can write letters with ink in that book, right? That doesn't go against the natural property of ink or the natural property of the paper, but the ordered information on them doesn't just come about by slapping ink around. In the same way, the ordered system that you see in the DNA does not come about just simply by throwing
this is just ridiculous.
chemicals together.
Well, that wasn't any fun at all, was it? I suffered for my sins. Or their sins, or so. I don't know how Christianity works. Anyway, I hope you get something out of it. I don't know. And I will talk to you sometime later.